Is Gausby from CSC department. My topic is gradient operator. Introduction to the gradient operator. The gradient operator denoted by delta. It is vector differential operator. It measures the rate and direction of change in scalar field. Understanding the gradient is essential in vector calculus and physics. Defining the variables. In the text, we define vector A as constant vector. The variable vector or represents the position vector in 3D space. The notation R denotes the magnitude of the vector. Next, we have to discuss the expression to differentiate. The expression we are analyze is vector A C dot vector R cap n. This represents a scalar field multiplied by power of distance. We aim to compute the gradient of this expression. And we have to discuss applying the product rule. To compute the gradient, we apply the product rule for differentiation. The product rule states that NAB is equals to FNABLA G plus G. NABLA F. Here F is equals to R cap N and G is equals to vector A. C dot vector R. And calculate the NABLA or cap N. The gradient of R cap N is given by N R cap N minus 1 hat R. Here hat R is the unit vector in the direction of vector R. This result will be used in the application of the product rule. Calculating the NABLA vector A dot C dot hash vector or hash. The gradient of hash vector A hash C dot vector or hash else hash vector A. This is because the product with a constant vector results in a constant vector. Thus hash NABLA hash vector A C dot hash vector R equals to hash vector A hash. Combining the results. We can now combine the results from the product rule application. This else hash NABLA hash vector A C dot hash vector R hash comma R cap n equals to hash vector A R cap n plus n R cap n minus 1. Hash vector A hash C dot hash vector R hash hat R. The next step is express this is a simplified form. Simplifying the expression. We can rewrite and hat R in terms of vector R hash and R hash. This leads to express hat R equals to fraction and hash R minus R. Hence we can substitute this back into our gradient expression. Final expression. After substituting we arrive at the final expression. The full result is NABLA hash vector A C dot vector R cap n equals to vector A R n cap n vector A C dot vector R n cap n plus 2 hat R hash. This shows how different components interact in the gradient operations. Conclusion. We have successfully derived the gradient expression for the given scalar field. And understanding the process enhances our grasp of vector calculus. This result has application in fields such as physics and engineering. Thank you.